All right, welcome everyone to our first afternoon session in the virtual showcase of undergraduate scholars. Our 1:30 session is the fabulous, well, some of the fabulous Chellgren Fellows. So we are excited to see what they have been working on this past semester. Just a couple of housekeeping notes. This presentation is being recorded, so if you would rather not appear on screen or anything, make sure that you're okay with that. And then also questions are encouraged. So what we will do is through the webinar feature, you should have a Q&A box at the bottom of your screen. And so if you have a question, and we would encourage everyone to ask questions, if you have a question, just use that Q&A box to ask your question, and our students will either be able to read that on their screens, or I will read it to them and they will get to your questions as quickly as possible. So thank you so much for joining us. Our first presenter today is Meredith. Meredith, are you good to go?
I am good to go.
Okay.
Okay, so hi everyone, I am Meredith Williams and I am a sophomore currently performing research in the Gentry Sun Lab within the College of Medicine right here at UK. One of the projects that I've recently gotten to be a part of deals with diminishing glycogen aggregates in the brains of Alzheimer's disease patients. And this is important research because Alzheimer's disease is the 5th leading cause of death in elderly populations, basically just people over 65 years of age. Alzheimer's disease is a progressive type of dementia that is actually very complex. We know that there are several different environmental and genetic factors, as well as some factors that have not been identified yet. There's currently no cure for this disease, so there are several treatments, and research is still ongoing in many facets of this disease. The presence of these abnormal sugar groups, the glycogen aggregates that I mentioned earlier, seems to be a hallmark in several different neurological diseases, but particularly for this project, we wanted to look at the aggregation in Alzheimer's disease. So what is glycogen? Glycogen is a storage molecule for glucose, which is one of the most important sugars in the human body. And there are several projects, ours included, that are researching the buildup of this accumulation, also known as polyglucan bodies or PGBs in AD. And we decided to tackle this process starting at the very beginning. So before accumulation ever occurs, trying to get it to stop. And we wanted to test out a way to stop production of PGBs by using antisense oligonucleotides or ASOs. And ASOs work to disrupt protein synthesis by interfering with the RNA for that protein. And so the ASO that we chose to utilize in our study specifically interferes with glycogen synthase RNA. So we tested this ASO using mouse models. And the mouse model for Alzheimer's disease that we chose to use for our study is the 3xTg model. And we did this using ICV injections. And this basically just means that we did a little mouse surgery and we stuck a needle in the mouse's brain to directly inject our ASO treatment right into the hippocampus. And then we let the mice heal and go about their lives for the next 4 weeks before we harvested the brains so we could run our tests on them. And the test that we decided to use focused on if there was knockdown of the glycogen synthase, looking at the levels of glycogen and other metabolites overall, and detecting where that glycogen was accumulated in the brain. And all this was done using Western blots, gas chromatography, mass spectrometry, or GCMS, because that's a little bit easier to say, and immunohistochemistry staining. So looking at the metabolomic data that we got down below, if you notice the black bars, those are the bars collected from the mice that were treated with our ASO treatment. And the gray bars are from the mice that were our controls. So they still went through the surgery, but they were just given a saline solution instead of the ASO treatment. So it virtually had no effect. And you can see that for all of the different metabolites that we tested for, the mice that were treated with our ASOs showed decreased levels in virtually every metabolite shown below. Moving to the bar graph at the top right of my poster, these were the results from GCMS. We were looking only at glycogen here. You can see that the level of glycogen present in mice treated with ASO was significantly lower than our control. And then moving on to the Western blots just right below that, the very first one was for GYS1. And GYS1 is an important protein in the glycogen synthase pathway. And you can see that there's almost no bands present on that Western blot, meaning that that protein was almost knocked down entirely. Versus right below it is a Western blot for actin, which is not what we were targeting in this study. And you can see the bands very clearly. So this means that glycogen was knocked down, but not anything else. Moving down below to the brains right there, these are the results from our immunohistochemistry staining, or IHC. So these brains were scans using really fancy telescopes or microscopes and analyzed through a Halo computer software. So the very first brain is a control brain, and I blew up the cortex for you so you could see it a little better. There is very dark staining at the cortex, as you can see. It's almost black, versus if you look at the control brain, at that same region of the cortex, it's just a light gray color, almost the same as the hippocampus. And that dark staining in the control is actually where the glycogen in the brain is found. And you can see that it's much more present, and even where it's located in the brain. Versus the ASO, where you can't hardly find it at all. So what does this mean? This means that our ASO treatment was able to successfully knock down glycogen synthase in the brains of these mice. We didn't do behavioral tests for these, so we're not entirely sure what that knockdown would mean if we were to do it in humans yet. And further research is definitely needed before we were to ever move this on to a human trial stage, just to determine the effects of this symptomatically. But these results do provide evidence that using ASO technology allows us to control glycogen metabolism modulation. And that's something that is very different and could definitely prove useful in humans and in Alzheimer's disease, and could potentially lead to partial reversal of some symptoms in severe cases, and even potential restoration of memories in these patients. All right, so now I'm gonna answer some questions. So one person asked, is there any dependence on exactly where you injected in the hippocampus? I'm not entirely sure what you mean by dependence. But I can tell you that we injected on both sides of the hippocampus, and that we injected there because typically that is where we actually find the most glycogen in the brain. So that was going to be the easiest way for us to see it.
Meredith, can you tell us if there was anything about your research that really surprised you or that you weren't expecting to find out?
That is a good question. I think what was most surprising about my research was in the metabolomics portion. We tested for more metabolites than just the ones involved in the glycogen pathway. And even those levels were decreased compared to the control, which I thought was interesting.
Thank you.
Mm-hmm.
All right, do we have any more questions for Meredith? All right, well, thank you so much. This is such important research and I really liked hearing about it.
Yes, thanks for having me.
Sure. All right, so Riley, oh, we just got another question from Meredith. Lynn asked, can you tell us how you got involved in research?
I got involved in research at this lab through the Chellgren program and also through the Office of Undergraduate Research. I was always interested in getting involved in research here at UK because I knew that I wanted to pursue either a career in medicine or potentially go to graduate school. And I knew that getting involved in research as early as possible would not only help me better understand what I was learning in my classes, but also just help me get to apply some things very practically. So I started emailing around and meeting with mentors, and I found the lab that was right for me.
Wonderful, thank you. And Lynn says, good job. All right, now our next presenter is Riley.
Sorry, I'm having some issues with sharing my screen. Usually this is not an issue.
Is it giving you an error or what's it doing?
It says that it's somewhere in my my system preferences, but I've never had this issue before. Let's see.
If you send it to me real quickly, I can see if I can share it for you.
Yes, that would be great.
If that would be easiest.
Yes. And what email can I send that to?
It's Emily, EMILY, dot SALLEE at uky.edu.
Okay. So sorry for this. This has never happened before.
It always happens at the worst time.
So it would seem. All right. Let me know if you get that or if I
Okay.
need to send it in a different format.
Okay. Jesse, we need your fun music while we're waiting. Or like the Jeopardy theme.
Ask and you shall receive. Hold on. Oh, it's coming. Oh. Maybe.
Did that get to you?
It just came through. Let me make sure it's going to open here. Okay.
Interesting.
Are you able to see it?
Yes, thank you so much.
Sure.
Sorry, everyone, for that. That's never happened to me before, but good afternoon, everybody. My name is Riley Droppleman. I'm a sophomore here at UK. I'm a Chellgren Fellow. And for the past semester, I've been doing research with Dr. Provenzano in the College of Pharmacy in the Department of Pharmaceutical Sciences. And for the past semester, I've been mostly building skills, but I've also been getting into this research about designing and making pain relieving drugs that act a lot like opioids, but do not have the same potential for substance abuse disorder as opioids do at the moment. So the University of Kentucky is an Appalachian school, and we have made it our mission to find ways to combat the opioid crisis, as well as aid those that have been affected by it. And this research works to do just that, in trying to find new opioids that can be used in clinical settings and be prescribed to patients, but do not have a higher susceptibility for those patients to use them and become addicted to those opioids. So the way that we do this is that we have been trying to target a different opioid receptor within the body, and that receptor is kappa. We have 3 opioid receptors in the body, and they are mu, kappa, and delta. The receptor that is currently used by the drugs that are in circulation, such as morphine, hydrocodone, oxycodone, is the mu opioid receptor. And the mu opioid receptor works really well in relieving pain, but it does have that higher affinity for patients to come back to the drug and use it in a way that is not healthy. And also it has higher risks for respiratory depression, which is what makes opioid use very fatal in some respects, because the heart rate slows down and you stop breathing. And that's how the rates of death have increased as a result of opioid use in America. And with kappa, whenever we target kappa, we can make ligands that work at this receptor site and still have the pain relieving qualities that are equal or even more than morphine, but do not have these side effects. Of course, kappa does have its own set of side effects, such as hallucinations or dysphoria, which is the opposite of euphoria. So a feeling of dread, which is why we are trying to put more research and more time into figuring out how the kappa opioid receptor works and the side effects that come with it. And we're trying to find ways to lessen these side effects, to give an opioid alternate so that we can combat the opioid crisis in America. So in order to make these kappa opioid agonists, the way that we approach it is with the Dmta cycle, which is design, make, test, and analyze. So we're going to try to make schemes that create these kappa opioid receptor agonists, and then we'll be in the lab actually making these compounds, testing them in vitro, and trying to see if they are in fact agonists at this particular site and if they're effective. So any compounds that we make that end up having a high selectivity at this specific receptor as opposed to the mu receptor, and ones that work well at this site, will be chosen for further analysis in vivo, so in mice and in rats. And the importance of selectivity is that you can make a compound that you might think might work at this particular receptor site, but it ends up actually working at mu or delta, or it might not be an agonist at all. It might be an antagonist, and it might work in the way that you don't want it to work. So we try to make the selectivity at the kappa opioid receptor site in the body as high as possible, so that we know that whenever we administer this drug, that it will work at this site and work in the way that we intend. And for the future, we're really hoping to utilize the properties of tiflidome, and tiflidome, which is shown on the right side of my poster. It is a benzodiazepine derivative, and benzodiazepines are prescriptions that we use as anticonvulsants and anti-anxieties. So they work well with people that have or experience seizures. They are known tranquilizers. So they don't exactly work in the same way as opioids do. But whenever we see tiflidome, which is a derivative of benzodiazepine, it actually works in a way that is similar to opioids as opposed to benzodiazepines. It actually binds at the kappa opioid receptor site, as opposed to any other receptors in the body and the ones that benzodiazepines usually attach to. So the behavior of tiflodome is actually like an opioid as opposed to a benzodiazepine. And this is really exciting because tiflodome can be easily manipulated through synthesis. It has many sites on it that we can substitute for different functional groups. And we can try to test out the strength of binding at the kappa opioid receptor site. And we can see how it works and what side effects it may have. So for the future, I'll be working with tiflodome, and especially this summer, I'm planning on making 20 analogs of tiflodome, and hopefully I'll be able to test most of those and see that they're agonists, and hopefully they work well enough that I can move it on to the next stage and do it in vivo as well, which is really exciting. So I am very excited to work with tiflodome and try to find ways to work against the opioid crisis that's currently happening in America, especially in Appalachia. And I'd like to thank the Chellgren Center for everything they've done. I'd like to thank the College of Pharmacy also for supporting undergraduate research. And I think that is it for my presentation. I will look at these questions. Lynn asked how I got involved in research. And I got involved in research through the Chellgren Center and through the Chellgren Fellowship. Thank you guys for your support in that. And I actually found my mentor by just cold emailing him. I went on to the College of Pharmacy website because I heard that they were a good place to go to for undergraduate research. And I have always been interested in pharmaceutical sciences, especially whenever it came to the opioid crisis. I mean, I have family in West Virginia, so I'm no stranger to understanding or experiencing the effects of opioid use with loved ones. So to be able to work with Dr. Prizanzano is actually a really great honor. But I reached out to him one day through email, and he was incredibly kind. He just asked for my resume and asked to set up a Zoom meeting, and it was as easy as that. I mean, I didn't think that research would come as easily to me as that, but all it takes is just an email, and sometimes you don't get it a response the first time, which I didn't with a couple of labs before that, but the ones that do respond are the ones that you want to be a part of. So that's how I got involved in research. And I have another question. They ask, is the binding affinity similar to opioids? I assume that you're talking about tiflodome. And the binding affinity for tiflodome is very similar to opioids at the moment. They bind very well to the kappa opioid receptor site in the body. They choose that site over any other receptor, and the binding is very strong at that moment. I have a statistic in here that actually talks about how tiflodome has this affinity at this site, and they also display a higher potency than morphine in some cases. So, thank you. Thank you so much for your comment. Thank you for listening. And I don't know if there's anything else, but yeah.
Do you have any other questions for Riley? All right. Thank you so much, Riley. That was really interesting.
Thank you all.
And I love the lights behind you.
Oh, thank you.
We have musical ambiance and lighting ambiance. I like it. All right. All right. So our next presenter is Madilyn. And Madilyn, I have to tell you, I saw a a few Flandermeyers in the audience. So you have a great cheering section here, ready to hear about your research. So whenever you're ready. You're muted. Be sure to unmute. I do that all the time.
There we go. That was different in the sharing version. So hi, everyone. I'm Madilyn, and I'm presenting my work, Understanding How Ambient Conditions Affect Work Function of Tungsten Cathodes. My research was conducted within the Department of Chemical and Materials Engineering with Dr. Matthew Beck as my faculty mentor. And so the purpose of my investigation was to understand how the ambient conditions, the atmosphere, versus the vacuum conditions affect on the work function of multiple tungsten samples. And work function is the minimum amount of energy required to bring one electron to the outside surface of a material. Understanding work function values is important for thermionic emission, which is important for lots of electronic devices that we use every day. And so all measurements taken during the investigation were on the ambient Kelvin probe, which is pictured here. And I'm going to show an enlarged version of that. And next to this, that is a detailed view of how the system works. So a sample is placed on the stage of the system and the probe tip is lowered to a gradient of 300 above the sample, which is so close it almost looks as if the tip is touching the sample, but our zoomed in camera will show us that the tip is not in fact touching the surface, which is important because the probe tip itself is oscillating above the sample during measurements. And so the tip is able to read the contact potential difference, or the CPD, which is a measurement of the voltage difference between the tip and the sample. So for this reason, it is very important that the system has good electrical contact between the sample and the probe tip as shown in the schematic. And at first, it was a little bit difficult to ensure this, but I can discuss during the Q&A how we overcame this issue. So a simple equation is used to calculate the work function from the measured CPD. It's the work function of the tip minus the CPD. And we know the work function of the tip because of a gold calibration sample. Gold is generally inert, and the tip itself is coated in gold, which makes it good for calibrating the system. The tungsten samples I used were a bare pellet, an osmium ruthenium coated pellet, a B-type cathode, and an M-type cathode. A B-type cathode is impregnated with barium oxide, calcium oxide, and aluminum oxide, and the M-type has the same impregnate plus the osmium ruthenium coating. So I can discuss the in-depth differences between cathodes and pellets during the Q&A. So switching over to the data, here is a zoomed in view of that. First in the graph, this is all of the 4 samples with their CPD measurements. So it's important to note that the graph is showing how different each of the samples is from the tip itself. So the graph is showing that the B-type cathode in gray is very similar to the work function of the tip, whereas the M-type cathode is the most dissimilar. So the table below has all of the work function values from the ambient conditions and the vacuum conditions. In general, there is a clear trend that the work function decreases in vacuum conditions. And as a quick note, there is a drastic change in the cathode vacuum data from the ambient data. That's because these numbers were not measured in the lab, but they are known values for the cathodes in vacuum conditions. And these cathodes are typically heated to well above 200 degrees Celsius, which also aids in lowering the work function values. So my investigation measured work functions for tungsten all within the known range, which is 4.3 to 5.22 eV or electron volts. And I originally hypothesized that atmospheric conditions would raise the work function values because of gases in the porous materials or water droplets on the surface of the materials. And generally this was proven in my investigation. And in a vacuum probe, especially when you heat the samples, gases and water droplets are removed from the samples. So it is not a factor in affecting the work function. Moving forward with my investigation, I would like to heat the samples in ambient conditions so that I could have a more detailed view of the differences between ambient conditions and vacuum conditions. So thank you all for listening, and I will take questions now.
If you could go back and kind of start this over, is there anything that you would do differently?
I would say if I could start over and I knew what how I could fix the gradient right off the bat to ensure good electrical contact, that would save me a lot of time in my research, and then I probably would have been able to go further and be able to heat the samples and include that data in this project.
Great, thank you. Do we have any other questions? Oh, here's one. How do you plan to heat the samples?
So that's a great question. That's something that we would definitely have to experiment with because as it is set up right now, the Kelvin probe doesn't have any heating mechanism on it, but it is definitely very possible to put some kind of thermal plate on top of this stage, but an issue there would be to make sure that the sample still has electrical contact with the system. So Lynn asked, why did I want to do this research study? And so, like I said, this research was done in the Department of Chemical Materials Engineering, and I am in materials engineering. So this work is directly applicable to what I'm learning right now in the classroom. And it's definitely something that is interesting to industry as well as I move forward in my career.
All right, thank you so much. That was great.
Thank
Very
you.
interesting. All right, and next we have Reagan. Whenever you're ready, Reagan, go ahead.
Okay. Okay. Hello, my name is Reagan Parker, and I am a sophomore Chellgren Student Fellow at the University of Kentucky. And today I'll be discussing my ongoing research with Dr. Hubbard in the College of Health Sciences Language and Cognitive Neuroscience Lab. My research is task-evoked pupillary response as a reliable biomarker of cognitive load differences for adults with hearing loss and/or cognitive impairment. Hearing loss and cognitive impairment are common chronic conditions with aging, but why does hearing loss matter? It has actually been shown that hearing loss can lead to more rapid cognitive decline in adults due to a variety of effects on independence and social well-being. Over 23 million adults suffer from hearing loss and almost 5 million from dementia, according to previous research. There are many speech, language, and hearing treatments and therapies to help these chronic conditions, and reliable assessment of cognitive abilities are necessary for treatments to be refined and most effective. These tools for assessment, like fMRIs that measure brain activity through blood flow during a task, can require significant expense and expertise. But there are tools that are more affordable and accessible, like eye tracking. Task-evoked responses of the pupil, also known as TERP, is measured with eye trackers and has been used to measure cognitive efforts in a variety of tasks. However, reliability has yet to be examined as a whole nor has reliability been investigated in subjects with known hearing loss and/or cognitive impairment. Therefore, in this study, there are two primary objectives. First, to determine if pupil size through TERP is a reliable measure of cognitive effort, and then to determine the effect of age, hearing loss, and cognitive impairment on cognitive capacity. Essentially, to give an overview of what exactly pupillometry and TERP have shown us thus far, take a look at the cognitive and emotional processing diagram in the bottom left. Here you can see that as cognitive emotional processing increases, pupil size should increase. This is the phenomenon that we observed in this study. By utilizing SR Research's eye tracker portable duo, TERP is collected in subjects with varying age, with or without hearing loss, and with or without cognitive impairment, through a speech and noise listening task. Within subject, a cross-session analysis will provide insight into the reliability of TERP. Comparison between subjects with different age, hearing loss, and cognitive abilities will provide insight into the effect of each variable on cognitive capacity. In our investigation, there are two primary variables being manipulated between trials. In each trial, there is a sentence presented in varying background noise levels, and the participant is asked to repeat the final word of the sentence. Signal-to-noise ratio was manipulated between trials, and it is the sound level of background noise compared to the sound level of the target sentence. For example, a high SNR would essentially be comparable to trying to understand me in a crowded cafeteria, whereas a low SNR would be comparable to listening to me speak in a library where there is little background noise. Closed probability was also manipulated between trials, and it is defined by the ability to anticipate the final word of the sentence. For example, a high closed probability sentence would be, Bob wore a watch on his wrist. A low closed probability sentence would be, the class is discussing the wrist. So as you can see, a high closed probability sentence, the end is very predictable, whereas a low closed probability sentence, the end is not so predictable. With different closed probabilities and SNRs, the difficulty of the task varied, thus testing cognitive abilities and capacity, which could be observed via pupil size. To better understand how pupil size was measured using TERP, take a look at the middle diagram. So each presented trial began with 2 seconds of silence, followed by 2 seconds of noise, and then the sentence begins with the noise still in the background for its length. After the final word is spoken, speech is off, and only noise remains for 2 seconds, and then the experiment and trial ends with 4 seconds of silence. So essentially, you allow a slow ramp up and a slow ramp down for the brain. And there are 15 different time points in each trial where pupil size is recorded. Each of them have significance to analysis. T1 is a recording in silence and gives a baseline of pupil size in silence. T2 is pupil size recorded during noise and shows the effect of noise on pupil size. T3 is the start of the sentence, or speech and noise. So T3 through T5 show the effect of speech and noise on the pupil. T6 is the final word onset, and T7 is when we recognize the final word. T8 is the end of the sentence and marks pupil size as the sentence ends. T9 is noise off, so it shows the pupil size in noise after speech and noise. T10 shows the pupil size adjusted back to silence and marks the pupil size prior to repeating the final word. T11 is the pupil size at the response in silence, and then we finish with a resolution of T12 through T15, which are simply just within the 4 seconds of silence, each given a second to measure how our pupil ramps back down after. Comparison of these pupil sizes between trials will give a better understanding of how varying difficulties of tasks with different SNRs and closed probabilities affect pupil size, all giving an insight into cognitive capacity. These recordings will give a precise marker for how pupil size changed throughout each trial and sentence, and will be used to compare trials within subject and trials between subjects. 15 time points and manipulating 2 variables allow this study to be multidimensional to compare reliability and the effect of individual cognitive characteristics on pupil size, thus allowing us to analyze cognitive capacity as a whole. So, what is the anticipated result of our experiment? We anticipate that TERP will be reliable, so pupil size should not significantly differ when comparing different sessions within the subject. Also, TERP will be a sensitive and reliable measure that shows age, hearing loss, and cognitive impairment do impact cognitive capacity, shown through the significant effect of the varying difficulty of the variables. And overall, it is predicted that pupillometry could provide an affordable, accessible, and a precise biomarker for treatment effects and cognitive ability. Thank you guys so much for listening, and at this time, I'd love to answer any questions. Let's see. Richard said, how is cognitive impairment being defined and assessed? So cognitive impairment, we're actually, when we obtain our clinical population, those will be pulled from Sanders-Brown, and those evaluations will be made and given to us and defined by the doctors over at Sanders-Brown. And then what type of hearing loss is being assessed? We have yet to determine that so far. Like I said, when we obtain our clinical population, we will probably get more into that. We had just actually finished building our experiment and are currently piloting. Our next step is to obtain the clinical population and to really define those variables and the range of hearing loss and stuff like that. And then it was also asked, what is the dB difference between the target sentence and the background noise? So SNR is essentially what he's talking about there. That is one of our variables that we decided an interval of 0, 2, 4, 8, 10, and 12. And 12 would be your highest. So like I said, trying to understand me in a cafeteria, and then 0 would be very simple, trying to understand me in a library with very little background noise. Thank you so much. Does anyone else have any other questions?
Lynn said great poster design, and I agree. I like your graphics.
Thank you.
They're really interesting.
Thank you.
Any other questions for Reagan? Okay, thank you. All right. And our next presenter is Kennedy. So Kennedy, whenever you are ready.
All righty. Good afternoon, everyone. Thank you for having me. My research focuses on a program proposal to decrease hypertension in African-American women. My name is Kennedy Brown, and I'm a human health science major coming from the College of Health Sciences. Before I begin, I do want to thank a couple people. I want to thank Dr. Brandy White for being my faculty mentor for this research. I want to thank the Chellgren Center and the Chellgren Fellowship for supporting my success in all aspects. And I also want to thank everyone who's here supporting me today. So a little background on why I decided to focus on this topic. Hypertension, so basically what that is increased blood pressure, and that can lead to different things like stroke, heart disease, and other things like that. And being an African-American woman, I'm already predisposed to these issues. So I really just want to focus on different health disparities and how to just overcome those to improve cardiovascular health for Black women. And so as you can see in the background, African-American women are disadvantaged in several ways when it comes to their health. They suffer from hypertension at a disproportionately higher rate compared to white and Hispanic women. And as you can see, the statistics say 47% of African-American women suffer from hypertension compared to 27% of white women and 36% of Hispanic women. And we know that most of these statistics are due to social determinants of health. So if you don't know what that is, basically those are different factors that can contribute to someone having poor health. So some of those factors can be the type of neighborhood you live in, if there's access to a grocery store nearby, if there's violence in the neighborhood, education level, income level. So all those factors, when they come together, can impact your health. So like I said, the purpose of this is really just to figure out what programs already exist to decrease the health disparities that exist and what programs need to be implemented to curb those health disparities. And so in terms of the methods, I created a survey that asked women who lived in public housing about their diet, and also it was on the survey about demographics and just other things like that, and factors that would contribute to them having high blood pressure, also known as hypertension. And so the survey had questions about education level, income, diet, if they had health insurance, tobacco use, chronic health conditions, and social determinants. And so after doing my research, I came up with a program proposal of my own, something that I think would be useful, even if it's not in the state of Kentucky, something that can even be implemented on the University of Kentucky's campus. And so what this program proposal is a Women's Center for Success. After doing my research, I realized that there weren't many programs or many resources catered specifically for women to help improve their health. And so basically what this center will be is a place for them to gain resources about healthy food options, exercise, do yoga, and even have something like a shuttle to take them to produce stores if they do not have fresh produce in their neighborhood. Coming from a city like Chicago, I've rode through neighborhoods where there were not many grocery stores, where there were not many access to things, and that in turn can diminish one's health literacy, and they won't know, what's available to them. So just knowing that, I believe that my program proposal will definitely enhance African-American women's health and decrease their prevalence to developing hypertension. So in conclusion, hypertension in African-American women is expected to increase over the next 10 years, but hopefully with programs similar to mine and people coming up with new policies, we can decrease the health disparities that exist. And so right below our conclusion, I have this comparison graph, and basically this just explains a little bit of what I was talking about. So when you have the social determinants of health and also risk factors coming together, that can affect morbidity. So that's things like heart disease, stroke, the disease that you can get from having, from living with poverty and racial discrimination. And also if you have poor nutrition and obesity, all those things come together. And in turn, that can lead to mortality if those issues are not prevented and treated ahead of time. And so I think another way to improve this is just having diversity within healthcare, and also diversity in our policymakers. And so, yeah, that's pretty much it. Again, I do want to thank my faculty mentor, Dr. Brandy, and the Chellgren Center and the College of Health Science for supporting me. And if you have any questions, I'll be happy to answer. So looking in the chat, it says, which part of the program includes childcare, since that can impede attendance at the proposed center? So that's a very great question. And thank you, Dr. Andriata, for asking that question. That will require more research and time on my hand, but I do think that childcare will be extremely important, because that also plays into part with health disparities. So that requires more research, but thank you for that question.
Kennedy, can you tell us a little bit more about the survey? I'm kind of wondering how many questions were on it and how it was distributed.
Mm-hmm. So for each section of the survey, like I mentioned, tobacco use, social determinants of health, there are around probably 10 questions. And so the survey was distributed to women who lived in public housing, since that's more of a specific sample size, a specific population to work with. And so that's how the survey was distributed to women in public housing.
Okay, do we have any other questions for Kennedy? You have a comment, a very creative and holistic proposal.
Thank you.
All right. Oh, and Lynn asks, how does this study relate to what you want to do with your career?
Definitely. So in the future, I want to go into medicine to become an OBGYN. And although that focuses on a couple aspects of women's health, it might not be necessarily women's health. I believe that health in general should all be interconnected. So you can't focus on one part of health without looking at the other part of health. So I believe that women's heart health is definitely going to be very crucial when I go into my desired health career, and just making sure that they are receiving all the access, all the accessibility that they need to be in the best health possible. Thank you for that question.
Excellent. Thank you so much. That was great. Very, very
Yeah.
interesting. Okay, and Jessie, Gabija is next, but I think we need to make her a panelist.
I'm on it.
I see her name, but she's not, I don't think she's designated as a panelist.
Done.
Yay! There she is. Perfect. Okay, whenever you are ready.
Hello, can you see the presentation? Sorry.
We can. Looks great.
Okay, so hi, my name is Gabija Ziemyte, and I'll be presenting an analysis of gamma ray detector data for the Ndtgaming experiment. I've been working with Dr. Crawford this semester in the Department of Physics and Astronomy, and we've been working with the Ndtgaming collaboration over Zoom as well, which has helped to gather the data and helped with the analysis aspect. So in this experiment, we are studying the neutron capture on the Deuterium nucleus, a deuteron, which is a heavy hydrogen. And upon the capture, it produces a tritium nucleus, and a gamma ray is emitted as a result of this, because the tritium nucleus that is produced is in an excited state, and as it comes down to the ground state, it emits a 6.2 MeV gamma ray. And so we're studying the correlation between the spin of the neutron as it hits the deuteron and the direction of the gamma ray that is emitted, because the interaction of the neutrons and the protons are dominated by the strong force, and there's also the weak force that's interacting within the nucleus. But the strong force conserves parity, meaning that any photons that are emitted are symmetrically emitted, whereas any asymmetry in the emissions can be attributed to the weak force. And this asymmetry is can be understood as a parity violation. And here you can see a mirror reflection of the experiment, where the directions of the gammas are different based on which perspective you're looking at it, and that indicates a parity violation. And so in the experiment, we have a polarizer which isolates one spin state. And then in the spin rotator, the spins are flipped from up and down, because we want to ensure that any systematic errors due to drifting detector efficiencies are accounted for. And as the gamma rays are emitted, the crystal detectors collect the data as pulses. And our goal is to use a trapezoid filter to turn the pulses into trapezoids, because the trapezoids are easier to extract the important information from, which is the energy that is emitted from the gamma ray. And so what I've been working on this semester is optimizing the parameters of the trapezoid filter to ensure that it has the most accurate energy reading from the pulses. And so the 5 parameters for the trapezoid filter are the rise time, the flat top, the delay time, since we're working with 2 trapezoids, the decay constant of the pulse itself, and the threshold for which an energy pulse is registered as a significant energy pulse rather than just noise. And so by adjusting these parameters, we can ensure that we have an accurate energy reading. And so to work on adjusting these parameters, we first run a sample of data through a sample trapezoid filter to establish a histogram of cobalt energies. And so though we're working with deuterium, we wanted to test cobalt first because we know what that emission spectrum is supposed to look like, and we can establish the correct energy scale for the deuterium when we analyze that data. And so when we plot the energies as a histogram of the cobalt, we can fit a Gaussian curve to it or a normal distribution to it. And we want to minimize the sigma value of that Gaussian curve. And by minimizing that value, we know that the trapezoid filter has been optimized. And so in order to optimize these parameters, we run the data through different samples of the parameters, we test different numbers for the parameters, and we plot those numbers, and the lowest value over here, which here is around 28 for the rise time, would indicate the optimized rise time. And once we run those, once we parameterize the filters, we can run the whole set of data through the trapezoid filter and plot the full emission spectrum. So here we have the cobalt emission spectrum for the lanthanum bromide detector. And in our experimental setup, we had on one side a lanthanum bromide detector and on the other side a cesium iodide crystal array, because part of these experiments was to also test the efficiency of cesium iodide as a detector. And so we first tested it with lanthanum bromide to ensure that our data looked how it was supposed to. And so here we have the two peaks from the Compton effect. And this third peak is due to the lanthanum bromide reacting or emitting gamma rays of its own. And then here we also have the deuterium emission spectrum run through the same optimized or trapezoid filter. And over here at 6.2 MeV, we're expecting to see a peak signifying the gamma rays from the deuterium emission, or the tritium emission itself, but instead we just see the Compton tail. And then we repeated the same procedure with the cesium iodide detectors, which you can see here that the peaks are less distinct because the detectors were less efficient at registering the energy emissions. And so in future runs of this experiment, we'll be testing different crystals and seeing how those efficiencies can better read the energy that is emitted, and to hopefully be able to see the 6.2 MeV peak that we expect from this emission in order to get a good grasp on the weak force and its parity violating effects. Yeah, I'll just wanted to thank the Ndtgaming collaboration as well, and Dr. Crawford as well. So I have some questions here. What was a challenge that you encountered during your research, and how did you work through it? There was a definite learning curve when it came to learning all the programs that I had to use, and because we used Root to analyze the data, as well as Octave to plan or plot the trapezoid filters at first and understand how those worked. So there's a learning curve in understanding how to go about those programs. And what did I learn most from working on this project? Well, definitely how to program better. And I was surprised to learn as much as I did about collaboration about physics, because a lot of this work was done in collaboration with Indiana University and Los Alamos National Laboratory. And it was nice getting to work with other physicists who'd been doing this for far longer than I have, and getting to hear some of their expertise on the topic.
Okay. Do we have any more questions? All right, great job. Thank you so much.
Thank you for having me.
Sure. And last but certainly not least, we have Jasmine. Welcome. And you are muted. Just keep that in mind whenever you're ready to go.
Can you see like everyone when I'm showing my gallery? Or can you all see yourselves? Okay, let me try and.
No, not at all. We just see you.
Okay, awesome. So hi everyone, my name is Jasmine. I'm a junior at UK. And today I'll be presenting a little bit about COVID-19, which is definitely something that's on all of our minds. Specifically, I'll be talking a little bit about caregivers during COVID-19 and sleep, stress, and alcohol use as major outcomes of this pandemic. So Dr. Maloney, my research mentor, is a sleep researcher, among other titles, and she collaborated with her colleague, an alcohol researcher, because they're interested in the ways in which the ongoing pandemic could change people's health behaviors, specifically related to sleep and drinking. An important part of this story is that we know that stress, excuse me, in general could cause increased drinking, and it can cause decreased or disrupted sleep. Of course, there's a bidirectional relationship between drinking and sleep. That is to say, some people would use alcohol as a sleep aid, but that's a very bad idea because alcohol is actually disruptive to sleep in moderate to high quantities. You may fall asleep faster, but you'll have disrupted, less restful sleep. So they went into this project with the hypothesis that everyone will be more stressed out because of COVID, because COVID-19 turned our worlds upside down, and that we might expect to see as a result of this increased stress an increase in drinking and poor sleep. We wanted the focus of this paper to be on caregivers because we knew that caregivers had way worse stress outcomes compared to non-caregivers, particularly women. Because all of a sudden you've gone from being a caregiver and a worker typically to a worker, a teacher, a housekeeper, and all of the above plus more. There are also stories coming up in the media of alcohol sales going up. So with all of this context, we decided to focus on caregivers versus non-caregivers, given the inherent stress that they have embedded in their lives. Looking at the methods, we engaged in a mixed methods project, meaning we used quantitative and qualitative measures of our outcomes of interest, which again are sleep, stress, alcohol use, and mood. We talked only to adults aged 21 and over with internet access for the purposes of this paper. We're only using analyses from our first survey. So this is a longitudinal study with 3 surveys that were given over 9 months. And today I'll only be presenting the results from survey 1. We also have qualitative data in the form of first and second interviews with our subsample population of participants, but I won't be talking about that in detail today. Basically, the analytic strategies for this particular paper was to look at paired sample t-tests for all pre and post-COVID outcomes and caregivers versus non-caregivers. This was a sample that was largely female, mostly white and highly educated. So this is not what I would call a representative sample by any means. And most of these I would like to add is for adults in the state of Kentucky. This is voluntary, so we recruited online. We used UK's CCTS to help us recruit. We used Facebook, we used other researchers, and what we like to call snowball sampling, which is when we told interested participants to basically spread the word. I'll be talking a little bit about conclusions through these figures. So looking at figure 2, this first audit is a measure of a number of drinks. And in this figure 2, what we're seeing here is the blue line is non-caregivers and the red line is caregivers. But what you'll notice is non-caregivers started out drinking more pre-COVID, but the lines actually converged. And at the end there, the caregiver line goes above. So drinking was basically stable for non-caregivers pre-COVID to COVID, but the caregivers drinking increased significantly. We also see a much more striking comparison with our PSQI scores. So PSQI stands for the Pittsburgh Sleep Quality Index, and higher scores on the PSQI basically means lower sleep quality. So we see that in both groups, there's a real reduction in sleep quality pre-COVID to COVID. But once more, we're seeing that caregivers had significantly worse sleep than non-caregivers. And the p-values are just to indicate that these results are statistically significant. In figure 4, what you'll see here is perceived stress. So perceived stress is a measure that we just measured in the present time. And we'll be able to compare and contrast a bit more using later surveys. But for this one, we saw that perceived stress scores were significantly higher again for caregivers compared to non-caregivers. Finally, looking at the depression symptoms, we use the CESDR scores. And even though non-caregivers and caregivers started off with very similar scores pre-COVID, these scores increased significantly for both groups. But once more, we see that the outcome was worse for caregivers. In the future, we have 2 more surveys that we're going to analyze. And again, this is all longitudinal in nature. And preliminary findings from the interviews that we did earlier did shed light on some of the reasons that caregivers were more stressed out compared to non-caregivers. And a lot of it has to do with all of a sudden, like I said, everyone was homeschooling essentially. Prior to COVID, people's kids had activities to do. So in addition to people parenting and working from home, they're also teachers plus more. So in my opinion, this is really important research, and there's a lot of rich data that came out of the qualitative interviews that I hope I'll be analyzing further in the future. These findings will ultimately be leveraged into an NIAAA app. And as always, it is incredibly important to thank our funder under the COVID Pilot Award, the Chellgren Center, the Chellgren Fellowship Program. And I'd also like to hugely thank Dr. Maloney for combining her passions and her burdens and leading this important project. So thank you to the team, and thank you all for listening to my presentation. Try and escape. Oh, I see 2 interviews. What was the most surprising thing to you about your study? And thank you for the compliments. But I would say the most surprising thing to me was how dependent our health behaviors are on our obligations to people. So during these interviews that were really interesting to me, people were saying, you know, they increased their drinking not because of alcoholism. We didn't see alcoholism as an outcome, but because they had nowhere to be in the morning and they could work from home. And that really surprised me. And I feel like it made me more aware that we have an obligation to ourselves and our own bodies, and we should be proactive about our health based on that obligation alone. Let me see.
What would you say is was the most difficult part of this for you?
For me, what was most difficult was finding a representative sample because this is voluntary. Like, I feel like it would be very interesting to see what the general population looks like. I think we're all hearing a little bit about each other's experiences during the pandemic, but you know, finding that representative sample because it was voluntary was really challenging.
Thank you.
Thank you.
Do we have any other questions for Jasmine? Okay, well, that wraps up our afternoon. Thank you to everyone for being here. Thanks to our fabulous Chellgren Fellows for sharing your research from this past year. And of course, thank you to the Office of Undergraduate Research for giving us this platform to allow the students to share their research. So everyone have a lovely afternoon. Thank you so much.